In this session, I am going to explain about the construction and working of an transformer. Transformer, the name itself clearly indicates that it provides transforming action of same energy type. That is, it transforms electrical energy. Transformer, the construction of transformer is quite simple. It carries two important features. One is winding part. Winding part are classified as primary and then secondary winding. Coming back to the and another part, it is very important, the part which establishes flux. So that part is called as the part which establishes flux are classified as core type transformer and then as well as shell type transformer. So these are the very simple elements of transformer. This winding action takes place by the concept of mutual induction. So the principle in which transformer work is mutual induction. Apart from that, it satisfies the Faraday's law of electromagnetic induction, that is E is equal to N into d phi by dt. So based on this core construction, it is classified as core type and then as well as shell type. So this is the most important features of transformer. Apart from that, the core is made up of generally iron core. Then silicon steel laminations are preferred in order to reduce the eddy current losses and then as well as hysteresis losses. So these are the two important constant losses, iron losses, that takes place generally when the core gets magnetized. Apart from this type of general distinction, the coils are wounded rectangular and as well as circular in nature. Generally circular types of coils are preferred, and in both core type and shell type, the lamination parts plays a vital role for reducing the hysteresis loss and then eddy current loss phenomenon. Coming back to the working principle of transformer, as we discussed in the constructional features part, there are two windings. One is the primary winding and the secondary winding. The principle of working of transformer is Faraday's law of electromagnetic induction, and the current principle and the flux establishment principle is given by the concept of mutual inductance. So transformer is a static machine. The transformation of energy takes place when both the coil and the core remains static in nature. That means no dynamic forces are observed during the working of transformer. So coming back to the working, transformer works under AC supply. So an alternating signal or alternating quantity, alternating voltage is applied to the primary side of the transformer, so which between two ends. So when there exists a potential difference between the two ends, an alternating current flow is observed around the primary windings, and all these primary windings are wounded around the one part of the limb of the transformer. So this primary winding, when it is wound, when it carries coil, the limb which is surrounded by the iron core gets magnetized and it starts mutually linking with the coil which is nearby to the primary coil. It is observed that changes made in the primary coil of the when changes are made in the primary coil side, there are also changes observed on the secondary side. So which means that the flux which is responsible due to the flow of current on the primary side in the core is mutually linked with the windings on the secondary side. So it is observed a small voltage is observed on the secondary side, and that voltage gets affected when the primary input voltage is varied. So hence the concept of mutual induction gets satisfied. So according to the concept of mutual induction, it is denoted as E is phi 1 is equal to N2 phi 2 divided by N1. So according to the concept of transformer, the voltage or current can be stepped up or stepped down. This step up and step down actions are the two types of transformer based on the voltage and current. It is classified as step up transformer and then as well as step down transformer. So both this stepping up and stepping down either of voltage or current depends upon the turns ratio of the transformer. So, while designing the transformer, turns ratio plays a vital role. So, and at the same time, it is observed that only voltage and current can be stepped up or stepped down provided the frequency on the primary side and the secondary side always remains constant. This is a basic operating principle of transformer. The transformer output equation, EMF equation, is given by E1 by E2 will be equal to N1 by N2, which means that turns ratio are in on primary and secondary side are directly proportional, while that of current ratio are inversely proportional. Current ratio are inversely proportional. So these are the two equation to be observed based on the voltage and then as well as current, the relationship between number of turns and with voltage and current. So the EMF induced in the transformers on the secondary side E2 is given by 4.44 F pi, or the basic EMF equation of an transformer. So this is the working principle of a transformer. Thank you.